guys, this is Mariana, and in this video, we're going to begin our study of radicals. So here we go. See here that we have written a radical with all its parts, and we're going to explain each part one by one. First, we have the radicand, which is this expression right here. We have apple to the power of m, where apple can be any number, okay? It is very important to understand that this apple or this expression will be positive or negative depending on the nature of the index. We're going to study this afterwards. For now, we just have to understand that the radicand is the expression below the radical sign. So the radicand is going to be apple to the power of m. Then we have n, which is going to be the index, okay? So understanding that this is the index is going to be an integer from 2 on. If the integer or if the index is 2, we read it as a square root. If the index is 3, we read it as cube root. And then from 4 on, we're going to use the th, 4th root, 5th root, so on and so forth. So we have to understand as well that a radical is a power. It is a power with a rational exponent, and it's written this way. What we do is that we keep the base of the radicand right here and its exponent, and we turn this exponent into a fractional one by writing the index of the root as its denominator, okay? And that's the only thing you need to do. So with this, we discover that a radical is also a power, so it is a power. This means that for radicals, apply analog properties from the powers, okay? So why do I explain it this way? Because if you already understand the properties for powers, then analog properties are going to apply for radicals. So it's something that your brain already knows, okay? So with this covered, we're going to go into the properties. So the first property is the product property. The properties can be read from left to right and from right to left, okay? It's going to depend on the way the exercise expresses it, okay? In this case, we're working from the one that is condensed to the one that is separated from left to right. So this is the nth root of two different things, apples and lemons in this case, or limes, whatever you want to call it. Then, if they are multiplying, we can separate them, keeping the same operation, okay? So we have the nth root of apple times lemon. It's going to equal the nth root of apple times the nth root of lemon, okay? This only applies when they are multiplying, okay? This is super important because there tends to be a confusion when we have these elements adding. It's not the same, okay? So keep this in mind. This is not correct, okay? Because remember that the root is a power, okay? And powers do not work this way, okay? When we do exercises, we're going to explain it thoroughly, but for now, just keep this in mind whenever you need to apply the property. The property is for the product, okay? Then we have the quotient property. In this case, we have the nth root of apple divided by lemon. And this is going to be exactly the same, but each root separated. I see here that I have to write down the fraction line. Here it is. Okay, so this is just the same. It's exactly analog as the product, but in this case, it's a division. So we separate the two roots, okay? We have one big one and we separate it into its parts for the product and for the quotient. Then we have the power property, which is kind of similar to the power of a power, okay? In which the exponent of the radicand can be placed completely outside the radical, okay? And we can place it right there, and most of the times we're going to see the expression written like this, and we will have to convert it into this, okay? To do other kinds of operations. Then, the last one, which is exactly as the power of a power, is nested radicals. In nested radicals, we have a radical sign and then another written. We can have two or n radicals written. In this case, I am using only two because it's always the same. And the only thing that we need to do is to multiply the indices of the radicals, okay? In this case, I am going to explain how this works exactly as the power of a power, because see right here that the exponent of apple is 1, okay? So I am going to write this apple right here. We're going to keep the 1, and then the first index is n. Yeah? And this would be written as this. And then, if we do it again, we have, apple to the power of 1 over n times to the power of 1 over p. If we multiply these two, we get 1 over n times 1 over p. And we end up getting this, that if we rewrite as a root, this whole thing would be the index. And this is what we get. Exactly what we got from applying the property. If you see it right here, it's exactly the same. Okay? So with this said, I am going to erase this right here, as it was already explained. And now we're going to move on to calculating roots, okay? As you can see, this video is a brief class of the theory that we need to know to be able to do the exercises, okay? There will be videos, there will be tons of videos with tons of exercises where everything that we're explaining here will be applied, okay? But first, it's important that you understand how the roots work, okay? So let's go into this part, which is calculating roots. We have a radical, the nth root of apple to the power of m. So understanding that this is our radical, we have three cases, which is one of the first things I said at the beginning of the video. We have the first case when apple is greater than 0. That means positive. When apple is equals 0, and then when apple is smaller than 0. These are the three cases. The first case, where apple is greater than 0, we have two cases, depending on the nature of the index. If we have an odd index, an odd n, we have one positive result. And then if we have an even index, like the square root, we're going to have two results, the positive and its opposite, okay? Then, when apple equals 0, then the result is 0, okay? Because no matter the power of 0, 0 power anything is going to be 0, okay? Whether the exponent is an integer or a fraction, which would be our root. So the nth root of 0 will always be 0. Let's write this down so we have it as a reference. The nth of 0. 0. Always. And then we have the last case, which is when apple, the radicand, is smaller than 0. So if we have an odd index, we have one negative result. And if we have an even index, like the square root, which is the most typical one, then this cannot be operated because it's not defined for the real numbers, which is the group of numbers we're working in. There is no real root, okay? You'll see that when we work with them, you'll see how all of this is applied. Most probably, if you are in SO3 or in SO4, you have worked with this already. So this is just a review, okay? So the next part of the theory These operations involving radicals. And this is when everything becomes even more interesting, okay? The operations are the following: adding and subtracting, multiplying and dividing. There are more that are going to be part of a second video. This is the first part. Now we're going to go into the second part after this one. So, adding and subtracting. What is the most important thing? See that we have in the operation these yellow squares. If you observe, which is a very important skill when doing anything in math, if you observe, the radicals are identical. So to be able to add or subtract, the radicals have to be exactly the same. It's like adding apples or lemons. You cannot add apples with lemons. Okay, they have different natures. Then it's the same with radicals. In this case, you add apples with apples and lemons with lemons. Okay, so if you have root of 3 and root of 5, those cannot be added because they are not the same. They are not like terms, okay? So the first thing that we have to observe when we add or subtract is that the radicals are exactly the same, both index and radicand, okay? So in this case, what we did is that we applied right here a common factor, okay? This is not completely necessary to do because when we operate with the radicals, we can do the addition or the subtraction directly, okay? So let's go for the examples. We have 5 root of 3 plus 7 square root of 3. So we see right here that both roots are exactly the same. So we can operate with them by adding them, okay? So it's like having 5 apples plus 7 apples, okay? So if we add these two, we get our result, which is 12. Square root of 3. And between the 12 and the square root of 3, there is a multiplication. Okay? If you want to apply the property exactly as it is here, then the square root of 3 would be the common factor of 5 plus 7. And it will lead us exactly here. Okay? Then, for subtracting, the exact same situation. And in this case, we see that the root is a square root of 5. Let's see right here. 1 second. So we have 3 square root of 5 minus 5 square root of 3. So see, if we see it right here, I thought I misread and I thought that there were 2 roots of 5 and it's not the case. Here we have a root of 5 and here we have a root of 3. I fell into my own trap. I prepared this for you to observe and I didn't remember and I fell. So this is important. And you can see that it can happen that if we don't observe properly and we go directly into doing an exercise, we are very bound to make mistakes. So in this case, we cannot add nor subtract these operations, like these radicals, because they are not the same. We have an apple and we have a lemon. So we cannot operate with this. So we leave it as it is. Okay? So this is exactly the same. We cannot do anything with it the way it is proposed because we cannot subtract radicals that are different. We have radical of 5, sorry, root of 5, and then we have root of 3, different things. And then the last one, 5 square root of 2 minus square root of 2. So here, see guys, that there is a very common mistake when a teacher asks, how many roots of 2 do we see here? So some people say 1, but some people say 0 because they don't see a coefficient here. Remember that if nothing is written, there is a 1, okay? So there is 1 square root of 2. So we have 5 square roots of 2 and a negative 1. So it's 5 minus 1, all right? So this would become 4. Okay. Let's continue with the next one. The next one is multiplying radicals. And in this case, it's just applying the property. The radicals that are multiplied need to have the same index. So we're going to have two different, more than different, two separated radicals that are going to share the exact same index as they are written here. And it's like two separate bedrooms that we are going to join together, okay? So the separate bedrooms are joined together and we write it as one bedroom. That means one radical, okay? So see here in the example, we have a square root of 3 times a square root of 2. So we have a square root and they are multiplying. So this will become 3 times 2. And this is square root of 6. And see here, guys, that we don't have the same index. This time I didn't fall into my own trap. Here we have a square root, and here we have a 3. So we cannot operate the way this property lets us because they don't have the same index, okay? So no operation can be done here with the information we are given, okay? Let's change color for a minute. So here we go. And we keep it just as it is, okay? Then, dividing radicals, it's exactly the same situation. We apply the property. Imagine that we have two apartments that we join together in the same one, okay? And these apartments are going to share the same index or the same roof, if you want to see it that way, okay? So each apartment is going to be written under the same roof, meaning that we're going to write only one radical sign and the same index. And we're going to keep the operation between the radicands, A and B in this case. So the example is root of 3 divided by square root of 21. So how do we operate with this? We do, a square root, a very big one, of 3 divided by 21. You might think this is ready, but always remember that we need to simplify. And this can be simplified by 3. This is 1 divided by 7. Okay? And here, guys, you have 3 exercises in which you are given the answer. So the idea is that you put into practice the things that were just explained to see if you get the same answer, all right? I really hope this was useful for you, and stay tuned for next videos and next topics to cover, okay? Bye-bye!